All right, welcome everybody to Organics Recycling, turning a natural resource into a solution. I'm gonna wait a couple more minutes while people continue to come into the room. But really quickly, share, if you wanna look at the slides that are gonna come up in the next couple minutes, that would be good. There's some instructions regarding how Zoom works, some basics, and also how the Q&A function works. So as you come up and develop questions throughout the session, please prompt those, please send us some questions and they'll hopefully get answered. Alrighty, so like I said, welcome everyone to the 2020 Summit for Recycling, and thank you all for attending our organic session. We are super excited about this session, Organics Recycling, turning a natural resource into a solution. All-star cast today, incredible speakers speaking on behalf of organics innovations and soil health, a lot of really interesting material that we'll be covering today. And so first off, I wanted to say thank you to our sponsor, BASF. So thank you for supporting this session. With that, I will give a little brief intro about myself. So hi everyone, my name is Fussell. I am the founder and CEO of Compost Colorado, or COCO. We are a compost collection service based in Denver. We collect food waste from mostly residentially as well as commercially using a bucket swap service. And so each week we collect members' buckets from their front porch and swap it with a fresh, clean bucket that we use to deliver local sustainable goods. So we are manifesting the circular economy to help connect folks to local sustainable businesses, and in the process, making composting super easy. I would be remiss if I didn't mention my two champions of the session that organized this really awesome session today, David Friedland and Tenzin Tashi. I'm sure everyone here knows David. David has been in the zero waste scene for quite a while. He's a CU Boulder graduate, interned with EcoCycle before then getting a public policy master's degree from DU. And now David has been with Eco Products as their sustainability manager for quite a while. If you look at his LinkedIn profile, he's doing some incredible projects with them, making them even more sustainable business. He's also on the Colorado Composting Council, and he's also on the Recycle Colorado, he's also a Recycle Colorado board member. So Tenzin has been a steward of zero waste for many years. She has a master's in sustainable international development and now works for EcoCycle as part of their canvassing outreach team. Tenzin's thesis for her master's program was about resource management in Tibet. So she has a lot of really interesting background in international waste management. With no further ado, I would love to introduce our next couple speakers that will be speaking for the next 20 minutes about focusing on soil and the wonderful science and innovations that are going on with that. We have Helen Silver with over 15 years in environmental and sustainable policy work. She now consults with her own business Silver Sustainability Strategies. She consults nonprofits and academic institutions to advance sustainable practices. And she also leads the Denver Sustainability Food Policy Council, as the chancellor of that. And she also co-launched the Colorado Collaborative for Healthy Soils, which we'll be covering in this session. And we also have Dan Matsch, who many of y'all know, who is the Compost Department Director and Hard to Recycles Material Director for EcoCycle. Dan comes into the resource management field through an agricultural background, which has lended itself as a vital asset for pushing through organic management policies, and has also helped spearhead EcoCycle's new carbon farming initiative, which we will learn about. So yeah, awesome stuff. I look forward to learning some more stuff now.
Great. Thanks so much, Van. Awesome introduction. Again, my name's Helen Silver, and I'm going to be covering the basics of composting science today. Next slide, please. So I'm going to be throwing a lot of information out to you over the next few minutes, but I want to keep 3 key messages front and central. First, compost is a key tool for addressing 3 global crises that we have. One is soil degradation, the second is climate change, and the third is food waste or loss. The second key message is that microbes are really the engine of life in both soils and compost, and carbon really is the currency or the linchpin that makes these soils and compost systems work. And finally, with compost, what we're really talking about is accelerating natural decomposition processes that help sequester carbon. So basically moving nature along a little faster than it might otherwise work to restore soils and improve farming. Next slide, please. So the first reason that we should really care about compost is we are in a soil crisis globally. Here on the right is a photo of, a diagram of soil degradation across the world. And you'll see that the orange is degraded soil and the red is highly degraded soil. And these cover a lot of the Earth's surface area. And in fact, a lot of the red, very degraded soil covers our major bread baskets. So we are likely to be in trouble in terms of food production from soils in the coming years. Carbon is really the linchpin of soil health, and to date, soils have lost 50 to 70% of their soil carbon stock. And so not only do we want to return carbon to these systems, but we need to keep what's carbon is there in the ground. And the reason for this is soils contain a ton of carbon that we don't want to release to the atmosphere, 3 times more than what's in the atmosphere currently and 5 times more than what's in plant and animal life. And compost really helps improve all this, 1, by directly restoring carbon, 2, by aiding plant nutrition and helping plant growth, and some other ways as well. Next slide, please. The second crisis that compost can help with is food waste. And in the United States, landfills are the 3rd largest source of methane emissions in the country, of anthropogenic methane emissions. And another related issue is that in the US, we probably only have decades left till we run out of landfill space. Here on the right, I show you that the average household in the US throws away about 329 pounds of garbage per month. Over 40% of that is organic waste that we could be diverting to compost and then into healthy soils. Food waste is also really expensive. It costs about $161 billion annually in the US. It significantly contributes to the climate crisis. If food waste were a country, it would be the 3rd largest emitter of greenhouse gases behind China and the US. And as I'll talk more about in later slides, it really diverting all this food waste to land systems has disrupted the natural nutrient cycle. Next slide, please. So modern agriculture and food waste has disrupted carbon decomposition and soil carbon sequestration that naturally happens in soils. And so on the right here, you see an unhealthy degraded soil. You can tell that it's unhealthy and degraded because it's light colored, which indicates not a lot of carbon, and it's very crumbly and sandy. Compare that with the soil on the left, which you can see is darker, indicating a lot of carbon. It has better structure, which indicates that microbial life is in there, that it will hold water better, etc. And compost will help us go from unhealthy soils to healthy soils much more rapidly. A technical definition of composting is the process of accelerating decomposition of organic matter and carbon by microbes under ideal conditions to produce stable carbon rapidly. Next slide, please. I don't want to go through the carbon cycle, but the main point of this is to understand that plants are basically solar-powered carbon pumps. And I start with soil health here because I feel that understanding the composting ecosystem is much easier once we understand how it functions in the soils. So most of the people think about a plant as much of its life occurring above ground in the form of fruits, etc. That's actually not the case mostly. Plants under ideal conditions send most of their energy that they get from the sun underground through their roots in the forms of sugar and carbon. And if you look down to the bottom of this diagram, you'll see the terms SOM, which stands for soil organic matter, SOM, turnover, and stabilization. That's where we're going to be focusing because under ideal conditions, that's where a plant's major source of energy goes. And what happens in this ecosystem in the soil is that the carbon that the plant has sent through its roots, microbes trade that with the plant for things like nutrients in the soil that the plant can't get to, and also things like disease-fighting chemicals. All of this leads to rapid carbon decomposition, ultimately stabilization of that carbon and sequestration. Next slide, please. Here we're going to focus on the rhizosphere, which again is the area in the root zone. And as you can see on the right, these black arrows indicate the root exudates. This is the carbon coming out of the plant, or the sugars. The microbes take that carbon and then excrete these metabolites, which enter the roots and contain micronutrients and other chemical fighting services. And basically, this is a constant process of decomposition, or digestion and defecation, basically, of carbon, if you want to think of it that way, that results in healthier plants, more roots, and healthy soil. Next slide, please. So the composting ecosystem is very similar to the soil ecosystem. Microbes, again, are an invisible engine of life, and carbon is the linchpin of the system that makes it work. People often ask, well, how do we get the microbes into the compost ecosystem? They're just there on the organic matter generally. There are fancy things you can do with compost, but generally speaking, you don't need to add them in. Organic matter is the food for these microbes. And we talk a lot about in composting carbon and nitrogen. If we think about carbon as the main meal for the microbes, and nitrogen is really their super vitamins, or something that activates the compost. Microbes are a lot like us. They need specific conditions to operate efficiently, in this case to decompose carbon efficiently. They need oxygen, so you'll often see people turning their compost piles to get that oxygen in there. They need an ideal amount of water, so not too much, not too little. You'll often see people adding water to their compost. And nutrition is super important. And what microbes like is a ratio of 25 to 30 to 1 carbon to nitrogen. So here on the right, and this is contained in the references, is a basic 4 diet plan for carbon microbes. And we have air, water, and then we have our carbon, which is often called brown feedstocks. And these are things that are like high in lignin or cellulose, and this is again is the carbon's main meal. And then nitrogen, which you really only want 1 part to the 25 to 30 parts carbon. These are things like grass clippings, fruit, and vegetable peels, as well as coffee grounds. Next slide, please. Temperature matters with compost. Compost goes through 3 different phases of temperature: a moderate temperature phase, a high temperature phase, and then a returning to a cooler temperature phase called curing. This is largely driven by microbial activity, which, like us, they emit heat and CO2 when they work. Next slide, please. Building healthy soils through compost builds clean and abundant water. I'll let you take a look at this slide in a few minutes, but basically you can see that there's little runoff when we have a healthy soil here on the left. Next slide, please. Compost greatly increases root growth. So you can see here, composted manure on the right performs best. And actually, interestingly, the chemical NPK is worse for root growth than control, than doing nothing to your soil. Next slide, please. So people often ask, like, how do we quantify all the benefits from compost? You know, we can do this on a local field level for carbon and other benefits, but it's hard to extrapolate these to larger areas. We will talk more about this when we talk about the Healthy Soils Coalition in the breakout room, but I would encourage you all to read the Marin County Carbon Project study. Next slide. So to me, the choice is really simple. Do we want a future that has a lot of GHG producing food waste, or do we want healthy soils? You'll often hear of compost called black gold. And this is a fairly easy choice, I think, to make. Thanks.
Thank you so much, Helen. Really interesting stuff. You know, as a compost hauler, I don't get to often learn all about the carbon cycle and the science behind composting. So thank you so much for sharing that. Dan, would you like to begin your session now?
Sure. Hey, everybody. Thanks for joining us. I'm going to talk a little bit about some of the policy-related compost initiatives that we have going on in the state. And I'm, really happy to report that there are several and a lot of exciting stuff going on. So I'm going to try to cover the opportunity and what's happening right now. Next slide. So picking up from where Helen left off, she was talking about quantifying the compost benefits. So a key point that I want to make here is that that compost has and compost and other means of building soil have the potential to be a major tool for drawing down excess atmospheric carbon dioxide. In order to use it as a tool, we need to get it used in agriculture. Currently, if you're a farmer, you're a mainstream farmer, the market is not telling you to build soil. You're competing in a worldwide, a global market, and if you don't have the cheapest price for your wheat or whatever, you're not going to sell it. So right now, there is very little motivation, or there just isn't money available for a farmer to concentrate on building soil. So all they have is for income is over here on the left, is what they get from crop sales. So Helen was talking about compost benefits. There's these 3 options here. Can we quantify the compost benefits? Can we quantify regenerative agricultural benefits? Can we create a carbon market? These are all ideas for creating more revenue for farmers. We thought that 10 years ago, we thought the carbon market was the answer. It turns out that it's really difficult to quantify this for an individual farmer or for an individual crop, because there is so much variability in agriculture due to climate and regional variability in soils. It's really difficult to say, yeah, this field here sequestered X amount of carbon, and we're going to pay the farmer for it. That's the idea with the carbon market, but it's very difficult to do that, and it's even difficult to tell a farmer specifically applying compost this spring is going to turn into X dollars this fall. So so we have to be really creative about how we do this. It's important. The takeaway is we need to give farmers a new revenue source to be able to use compost. Okay, next slide. So what are the obstacles to doing this? Go ahead. Next slide. Okay, so one is this audience knows well that we are doing a lousy job diverting compost right now. Only about 5% of the organic MSW organic waste in the state is composted. So that we're not taking advantage of this potential resource for fighting climate change. Next. So here's another major challenge that we face in Colorado, and really pretty much between the coasts in the United States, where landfills are cheaper than compost facilities, and that is not a knock on compost operators. It's the reality that we face is that landfills are very cheap, especially in the West. So here's the economic realities that we face in Boulder. Our total cost to landfill is in the blue here on the left. It's around $30, whereas the total cost to compost Boulder's organic waste is roughly 3 times that, due to the inherent extra costs of turns out it's more expensive to make compost than to throw it in a hole in the ground. So so that's a reality, and then then we have a significant haul cost as well. Next slide, Van. Okay, so here's the reason why we have this large transportation cost. We have one regional compost facility for the entire Front Range. It is, it's all things being equal, it's well situated. It's located well for to serve the entire Front Range, but it doesn't address that problem of being more distant and more expensive than the landfill. So this works, say in San Francisco, where the landfill is already 100 miles away, and it's already maybe $100 a ton. But we have to face the reality that we have in Colorado. Next slide, please. So here's what I would suggest is a better model in Colorado, that we have more of a distributed model of compost facilities, perhaps one for every county. That's what we're working on in Boulder County. I often use the analogy of, every community, even my little town of Lyons, has a wastewater treatment plant. Shouldn't every community, or at least every county, have its own compost facility? Not to suggest that compost should be operated as a utility, but just to make those economics work. Next slide. Getting back to agriculture here, we also have an additional challenge here in that landfills aren't the only, or organic waste in landfills is not the only source of greenhouse gas emissions from organic waste. We also have, especially in Colorado, we have significant greenhouse gas emissions from dairies and confined animal feed operations who typically put their manure in a lagoon, and it sits there until they're ready to dredge it out, and meanwhile it is emitting significant amounts of methane. And then we have the carbon dioxide emitted every time that you disturb the soil, you create a carbon dioxide plume. So right now, agriculture is a significant emitter of greenhouse gas. We need to change that paradigm so that they are actually a sequesterer of greenhouse gases, carbon dioxide. Next slide. Okay, so here's what's going on. You may well know that Recycle Colorado sponsored a bill or wrote a bill last year that was well received by the legislature, HB 1047. Well, the idea of that bill was to create a statewide organics management plan, and the key elements are that the bill was to study the volumes and locations of the existing organic waste, and this is not just MSW organic waste. This would include all the manure that is being generated in eastern Colorado. It would include biosolids. It would include the accessible food waste or accessible wood waste as well. So once you know where those sources of organic waste are, then you're looking at what are the gaps in the infrastructure. Where can we add a key compost facility to better capture that stuff? So where we left that bill is, unfortunately, it was a victim of COVID, but the sponsors are interested in sponsoring again this year, so we can bring that back up. Next slide. So Helen already mentioned that we have a Colorado Collaborative for Healthy Soils that is, it's the Department of Ag and Helen's team are looking at does agricultural sector see a value in creating a healthy soils program, which is a key phrase for building soil. It is the challenge with this is keeping compost connected to the healthy soils program, because farmers don't always want to talk about climate change, but we need to in this case. We need them to understand that this is an economic opportunity for them if we can do things right. Next slide. So in Boulder County, we're taking advantage of the opportunity that we have from the state government owning a lot of the county open space, owning a lot of the agricultural land. All the green on the left side is open space agricultural land. I'm sorry, on the right side. And here's a picture of a trial that we're doing that is basically demonstrating the Marine Carbon Project's work in California. And lastly, next slide. Just want to mention a little project that we're doing at EcoCycle. We're trying to, we have a backyard carbon farming campaign where it's basically, we're trying to figure out, can you measure carbon sequestered in urban soil, but also more importantly, create a platform to educate the non-ag public so that they can influence agriculture and ask for carbon sequestration as part of agriculture. Okay, that's it for me.
Well, thank you so much, Dan. So much interesting material here. I have a few quick questions before we move on to Monique and Demitra. One quick question we had from the audience is, and you kind of just mentioned this, is how does someone get involved with soil health research and activism in Colorado?
Well, I would say there's two options that are readily available. One is to join the Colorado Compost Council. So that is that's a committee of Recycle Colorado. And we welcome composters and non-composters alike. There's also an opportunity to join the project that Helen heads up, that the Colorado Coalition for Healthy Soils. That's talking to the agricultural sector specifically. But you know, I think it's important that we do talk to the agricultural sector. We need them, and so we need to get that dialogue going. So that you'd be welcome there as well.
Great. Thank you so much. Helen, I have a question for you. How do researchers measure carbon sequestration? What equipment and technology is used?
That's a great question, and you'd think it would be a straightforward question as to what's the best way, and that's actually something we talk about a lot on our science and practice group in the Colorado Collaborative for Healthy Soils. Probably the oldest technology and one that most people are familiar with, but we are developing other ones and favoring other ones, is called loss on ignition test. And basically what you're doing is you are igniting soil, putting this really simply, and seeing what carbon is left after that. So you weigh the soil before and you weigh the soil after you've ignited it and see what essential elements are left there, and you take out all the gravel, etc. But there are several ways, and I'm happy to talk more about that during the breakout room.
Thank you so much, Helen, and thank you for emphasizing the breakout rooms. Just a reminder, everyone, that we will do breakout rooms for each of these pairs of speakers. So there'll be 3 different breakout rooms, and after we go through each set of groups, please rename yourself with your designated or interested room that you'd like to be placed in, and we can ask more questions to the speakers then. Moving along, I would love to introduce Monique DiGiorgio and Demitra Biddle. Monique is a fellow compost collector, co-owner of Table to Farm Compost in Durango, Durango's only curbside collection service. She's also the director of Local First, which supports local and nonprofit businesses. And she's been an environmental activist since she was 16. So bringing a lot of passion to her composting operation. Demitra is a sustainability coordinator and environmental management graduate student at Western Colorado University. She manages their new industrial rocket compost system, which is a really interesting piece of technology that rapidly composts food waste, and you'll learn more about that in just a second. So Monique, would you like to begin your session, please?
Yeah, thanks for the introduction, Van. And you probably can't hear it, but it's actually pouring here in Durango, so it's a really good thing. So yeah, as Van mentioned, we are the only curbside compost business here in Durango in La Plata County. Our mission is to provide organic waste collection to the residents and businesses of the county, to create nutrient-rich compost and soil amendments, and to support soil health and local agriculture through the distribution of compost and artisan soil. Really, we consider ourselves climate activists, and we're actually looking to rework our mission to really speak more to the environmental piece of why we're doing what we do, which you heard so much from Helen about that. And so we're really using Table to Farm Compost as a business and tool to create positive change. Next slide. So the history of Table to Farm, I'm not the founder. David Golden founded it in 2016. I purchased it in 2018, literally about 24 hours before it was going to go under. It was kind of a labor of love. And then luckily found my current business partner, so we both co-own Table to Farm Compost, Taylor Hansen, about a year ago, and that's really given us the capacity to grow the business. During that time frame, I did take the first next cycle kind of business incubation course through CDPHE, and that really is where a lot of the ideas around the artisan soil became fully baked, so to speak. And so the both the investment from CDPHE to take our business through this incubation, as well as the grants that you're going to hear about that we received, 2 in particular, have been instrumental in the development of this business. Next slide, thanks. So one of the things we have down here in Durango, Colorado is a lot of space. So you heard Dan talk about some of the challenges of compost production in the Front Range. We have kind of the opposite situation. So rural advantage for us is that our farm, for example, is 15 minutes away from downtown. It's actually kind of to the right of the screen here. And so we have a really kind of tight operation. Transportation costs are not a big issue for us. You know, to give you a sense, so for those folks that are up in Denver County, you're looking at 154 square miles for 619,000 people. We have 1,700 square miles and 56,000 people. You know, what that creates, that advantage also creates a bit of a disadvantage in that, you know, we have less people that would sign up for service, although just last week we hit 400 customers. So just kind of an interesting example of how a compost operation would work in a rural community and what some of the advantages are for us. Next slide. The other thing I wanted to speak to is really the business model that we use. It's really been a bootstrapping type of a business. David Golden started this with literally a 5-gallon bucket and a truck. He didn't even have a trailer when he first started. And when I purchased the business from him, I kind of continued along that path. And then when Taylor became co-owner, we really tried to make sure that we didn't have outside investment. Kind of going back to the fact that we see ourselves as climate activists, we want to make sure that you know, there's alignment. So we've tried to keep it pretty tight, and it's been thanks to the grants that we've received that we haven't had to look for that outside investment. So a little bit of a different business model. Next slide, please. So this is where the fun starts. Our first RREO grant that we were able to receive down here last year, we were awarded in December and then just completed the project this year. And it was end market innovation, really taking that artisan soil concept to fruition. And we are so pleased to say that we were able to use the funds from CDPHE to create Table to Farm artisan soil. Part of our goal was to be innovative in the use of materials in our artisan soil. So we were really, really dedicated to making sure that we are using recycled materials. So for example, we have wildfire mitigation happening in Archuleta County and biochar being created as a result. So we started looking for sourcing materials like that biochar locally that's in our artisan soil. We do pick up glass along with food scraps. So we're, instead of sending it up to Coors, we thought, well, maybe we could reuse it here. So we did purchase a glass crusher, and you'll see a picture of what that looks like. It adds silica and drainage to the soil. And then, of course, we also have an interesting business model where we've got a customer base that's interested in the product. So part of our innovation was like the end market was there, right? There were our customers, and in addition to the dividend that they do receive of compost, we were able to connect with them, value aligned on this particular presence. And then we had set up a Shopify account, which actually ended up being really, really valuable in the time of COVID, and we made quite a few sales through there. So next slide. So to give you a sense of how this grant was able to give us really a boost in terms of equipment, these are the fun pictures. Top left is the rotochopper bagger, so timing by time or weight, we're able to bag 2 cubic foot yard bags and then seal them. And then we also got a tub grinder, which was really just kind of a Kuhn mixer. You can see it in the bottom left. It's for mixing grain. And so we were able to put all of our constituents, including water, in that grain mixer, and that really gave us a nice final product. We also purchased a hopper, which is the bottom right, to really help facilitate kind of us being able to move material from the hopper into what is the trommel that you can see there, so that we can get a really fine compost. And then we ended up having to use 2 tractors at any given time. So the guy in the top left there, Pat Kane, had another tractor. So we were able to really like dial in our product, and within a couple days we were able to bag a couple hundred bags of 2 cubic foot bags of artisan soil. Next slide, please. So this is our glass crusher. Just wanted to show this picture to give you the backdrop and also just kind of mention that it was probably the biggest constraint for us in terms of time, being able to really kind of, work that into the soil. It was kind of a constraint. Also, we think that the glass makes the soil look really unique and interesting and quite beautiful. Some customers are really uncomfortable with it, and kind of back to our climate goal, we're committed to keeping that in there and instead educating them on why is glass in there. So both Taylor and I and the rest of the staff have had many conversations about reusing constituents and materials in the system. Next slide. Which gets us to that circular economy. So our goal is to keep resources in the system as long as we can. So whether that's money, so being able to have people buy compost and artisan soil locally, or if that's a resource like glass or wildfire mitigation, it's all about that circular economy and building that local self-reliance. So if you look at the soil label here to the right, you can see that we're trying to educate our customer base on the biochar. All of our wood and carbon comes from Durango Wood Company. And then we are a seal of testing assurance approved compost. And so we have quite a few things that we're trying to do to not only have a recycled product, but a high quality product. Next slide. And this is the bagged soil. We are trying to move away from the plastic bags. If you go to the next slide, because we're running out of time. We are looking to see if we could use these burlap bags. This is typically what we give our dividend of compost back to our customers, and they work really great. You just can't seal them quite as well, so we're still looking at that. Next slide. I want to be able to talk about the infrastructure grant. So the second grant we were able to get this year, which brings us to about $300,000 of investment from CDPHE, is to build La Plata County's first Class 3 compost facility. We're so excited. We're working through the Class 2 permit process with the county. When they developed the code, they did not imagine what it would be to build a compost facility. So our goal is to have that certificate of designation here by the end of June, and we ask that you wish us luck. Next slide. So from here, we're hoping to scale up once that facility is done. And hopefully that's looking at things like bringing beer mash to our larger facility and really developing regional markets. I think I'm out of time. I could talk so much longer. Thanks, man.
Thank you so much for all of that, Monique. We are running super short on time. There's so many questions I have for you that we'll have to get to in the breakout. So Demitra, would you like to go ahead and begin your session?
Yep. Hi, everyone. I'm Demitra. Next slide, please. I'm going to be talking about composting infrastructure at Western Colorado University in Gunnison, Colorado. Next slide, please. So currently we're working on a pretty big industrial composter project with the goal of keeping our food waste on campus by creating closed loop systems. Next slide, please. So we're achieving this goal through our rocket composter, which can divert up to 95% of Western's food waste. It's capable of composting raw and cooked fruits and vegetables, tea and coffee grounds, dairy, grains, cooked and uncooked meats, biodegradable plates, cups, napkins, and utensils. It's pretty cool. We can speed up the composting process to 14 days by enhancing biological processes. We have complete control of aeration, moisture, and temperature, which all create an essential environment for microorganism growth to transition waste to compost. We learned a little bit about that from Helen's presentation. So we control the aeration through blades attached to an internal shaft, which is controlled by a motor that rotates every hour. Then to control the moisture, our rocket is placed at a slight incline. You can tell a little bit, the right side's a little bit higher to control the moisture levels. So this allows the moisture to pool at one end of the composter at the stage where it requires more moisture, and then it drains out, and then we have a temperature control system. Next slide, please. So our compost ingredients are air, water, carbon, and nitrogen. Again, the air is provided by those internal blades inside. The moisture is provided by our food waste and wood chips, and then the carbon and nitrogen also by our greens and our browns. So the carbon nitrogen ratio is about 20:1 to 30:1. And then our moisture level needs to be around 57 to 67%, and then oxygen from 6 to 21% to streamline our process. So once our food waste goes into the rocket, it undergoes 4 stages. The first stage is where the bacteria and fungi grow that are required for decomposition. And then our stage 2 is where the energy conversion happens, and our temperature control increases the temperature to be from 40 degrees Celsius to about 90 degrees Celsius. And then this organic degradation kills any harmful pathogens in the food waste. Then that leads into our last stage, our third stage, which is cooling, where the temperature drops to 30 or 40 degrees Celsius. And then to our last stage, which is external maturation, where we produce our nitrites and nitrates, which are needed for plant growth. And that stage takes about 6 to 8 weeks. Next slide, please. So a big component of controlling the moisture level of our food is our food pulper. So this was installed by our partner in this project, Sodexo, the food service provider on Western's campus. So our food starts in the Rare Cafe where Sodexo provides it, and then the students put their food waste on a conveyor belt. And then a Sodexo employee will put the food down a chute into the pulper where the food is broken down into small pieces and any excess moisture is removed. It then empties down a chute into these lined trash cans, which a Sodexo employee or a lead sustainability student can walk a few yards away and transfer the waste into the rocket. Next slide, please. So to start the rocket process, we need compost that's already been made, wood chips and pulp, and this helps streamline the beginning process of it and build up the microbes necessary for decomposition. And then we transition to feeding wood chips and pulp. Since we have a pulper and it removes a lot of the moisture, we use about 1 bucket of pulp to 3/4 of a bucket of wood chips, depending on how wet the pulp is. And then it goes through the rocket process and the compost exits and we move it over to a maturing station. Next slide, please. So then we keep our compost on campus through our campus gardens. We have the Chipeta Dorm Hoop House, the Pinnacle Dorm Greenhouse, and then a Chipeta Outdoor Classroom to create a strong emphasis on our campus health through gardening and compost. We have educational signs up and we really aim to have students know about our composting process as well as have access to any vegetables that they may need to stay healthy. Next slide, please. So at its heart, this really is a demonstration project we want to show other communities the feasibility of reducing food waste through the use of an industrial composter. And while Western is a relatively small area, our project could be tailored to larger areas. We're in constant communication with Vail Resorts, the town of Telluride, Gunnison County, this Gunnison School District, and then one school district on the Front Range. They're all tracking our process on this, and we really want to demonstrate a good model for other places to install compost infrastructure similar to ours. Next slide, please. That being said, our successes and failures pave the way for future projects. We really want to share our outputs as far and wide as possible. We want to educate however many people we can about our sustainability infrastructure and demonstrate how a student-driven project can be successful. Next slide, please. So while the rocket has a very unique internal environment, it's located in a very unique external environment. Gunnison can get extremely cold. At times it can reach -40 degrees. and at least a few weeks a year, we're below zero. So this has created weather issues, and they've been a learning curve. Tidy Planet, the rocket manufacturer, has really been working with us on this. They want us to be successful, and we want to pave the way for colder communities to implement projects similar to ours. Some of our plans moving forward regarding the cold include putting in some temperature monitoring sensors, and then replacing our motor that turns that internal shaft with one more suited to colder temperatures, as well as exploring different lubricant options that may also be more suited to colder temperatures. Next slide, please. So Gunnison County is well suited for a project like this one because we have a strong sense of community support, as well as Gunnison is a tourism-based community, so we really have a lot of people coming through that we're able to educate on our sustainability programs. Next slide, please. Our project would not be possible without a whole lot of people helping out. So we have a lot of actors within the school, but we also have the City of Gunnison, Gunnison County, and the Colorado Department of Public Health and Environment helping us out with this project and making sure we're successful, as well as Sodexo, our food service provider. Next slide, please. And our project was made possible and thought up by our lead sustainability students on campus. They wrote our RREO grant that made our project possible. And this program is really cool. It strives to create advancement opportunities and real life experiences for students from any background or any major, with a goal to say that anyone can be involved in sustainability and to add value to our programs and projects, as well as build a culture around sustainability and compost on our campus. Next slide, please. So going forward, we're hoping to hire one full-time staff member dedicated to sustainability coordination, and hopefully widening the scope of any feasibility studies we could do on solid waste management in Gunnison Valley. Next slide, please. Thank you. I can take any questions.
Thank you so much, Demitra. Awesome stuff. I would love to have one of those rocket composters myself. So I'm lime green jello over here, wanting to use it and check it out sometime. We're rushed on time. So with this, I'd like to introduce Shawn Bruckman, the Colorado Operations Manager for Honeywagon Organics, a Class 3 composting facility in Eagle County, and co-chair of the Colorado Composting Council. She's also super active in education. She teaches K through 12, composting, recycling, and soil health. And also want to introduce Clinton Sanders, who joined A1 in 2018, brings a lot of marketing experience and bringing their marketing into the 2020s. With 8 years in the national food industry, he is really helping them with their brand initiatives and helping them complete that loop. So with that, Shawn and Clinton, would you like to begin your presentation?
Yeah, hi guys. Thank you for joining. Thank you for being here. We're excited to talk about it. We want to let's make compost sexy. I'm Clinton T. Sander, like they said, and I'm the marketing manager of A1 Organics. And I'll let Shawn introduce herself. We're going to tag team this presentation. So we're going to jump back and forth a little bit and go through a few things, talking about economics, talking about contamination, and talking about the value in public and private partnerships and how much that has brought to the composting industry. Also, I'm going to go into two innovations. Shawn's going to go into one about culture shift, and I'm going to go into one about a new composting process that we use called an MSAP process. Go ahead, Shawn.
Thank you. Yeah, it's so great to be here. I'm really excited to share this with you. Just a little bit more background. It was really nice having Monique go before us because she's kind of in that grassroots, starting from what the community is wanting. And that's where I started in the Vail area of Colorado. And now I'm kind of in this transition more towards what A1 Organics does as our largest composter of the state, or A1 has to deal with a lot of material coming in, and that's a big responsibility. And we're kind of in the middle of that transition and getting a little bit more. We just got our class 3 commercial compost facility designation. And so we're learning now what A1 has been trying to teach us for so many years. So we're going to tell you, we're going to kind of speak from the perspective more of the commercial composter, of dealing with all of this stuff coming in and trying our hardest to turn it into a valuable resource to get it back to the soil where Helen and Dan told us so much about.
Great.
So go ahead. Yeah. So just to, I'll kind of start out here, just to let you know, we all started composting for the same reason that we keep talking about, right? It's the right thing to do. We all want to compost. It's good for the soil. It's good for the environment. It's good for climate. But it puts us in a hard place here as composters. It needs to make sense too. So it is the right thing to do, but we can't just do it because it's the right thing to do. It wouldn't be sustainable economically if it didn't make sense economically as well. So that's our challenge, Clinton and A1 Organics and myself at Vail Honeywagon, and really all the compost producers around the state. We have this challenge to make it make sense while we're doing it to make a better place to live. So go ahead to the next one. And we wanted to take a little bit of time to tell you all about some of the costs that you might not realize that come along with composting, and that we have to hold as composters. We have a great responsibility as composters in the state of Colorado and in the United States. We are composting, so we are creating a biological control mechanism to protect public health and the environment. And with that great responsibility also comes a lot of cost as well. So Clinton and I are just going to take a couple minutes to tell you about some of the things that you might not have realized that are really big costs for us as composters, and things that we have to think about that sometimes you don't realize kind of falls on our shoulders.
Exactly.
Clinton, did you want to? Mm-hmm.
Yeah, no, it's just, I mean, real quick, like labor permits, environmental compliance, technology, equipment maintenance. All of these things are big economical costs that we have to face, like large equipment and things. So yeah, go ahead, next slide. And like Shawn can speak to this one. I'll speak to the next one. Go ahead, Shawn.
So yeah, there's just a lot going into developing a compost facility. And as Monique is going through right now with figuring out the cost of building a class 1 facility, there's a lot of capital costs. So you see a lot of pieces of equipment on this slide, and any one of these pieces of equipment costs anywhere from $200,000 to $600,000. And that's just one piece of equipment. And as composters, we have to have many pieces of equipment. Tenzin, next slide, please. And there's also a lot of costs associated with operations as well. And another example of some of the costs of that is our groundwater testing. So alone, groundwater testing, we spend $25,000 a year just testing the water to make sure that it's safe for all of you and our communities and the environment. And so there's a lot of costs that go into that. And Clinton, what are some of your costs?
Yeah, I mean, in additional to all the the equipment and the expensive equipment, you have to think about the labor that takes to run that equipment, the maintenance to keep that equipment maintained and continue to operate. And if we don't have those large devices and they go down, then we can't process the material that's coming in. So we have to keep them running. We have to keep them efficient. So that's important. And then another good example of something that you wouldn't necessarily think of is that top right photo in the background there. You can see all of that tall fencing. That fencing was specifically installed at our Keensburg facility to help reduce litter control from contamination, from plastics and things coming in on food waste, so they won't blow into our neighbors. Because if we make our neighbors upset, we got problems, and that's important. So we had to implement and put that type of device in, and that's a big capital expense. It's not cheap to put miles worth of fencing in. So next slide.
And so we just, this is just kind of a summary of some of the costs, operational and capital costs that are incurred by different types of compost facilities. And the summary is that it costs us about $40 to $140 dollars per ton to produce 1 ton of compost. And as you know, if you've ever bought compost, it doesn't cost, we don't get that much back in the sale of our compost. So we really have to justify that in other ways. We have to have tipping fees. We have to be creative about where we're justifying all of this and making it really make sense. Go ahead to the next slide. And so one of our biggest costs is contamination. And Clinton's going to tell you a lot more in detail about that, but that is definitely a big cost for us as composters.
Yeah. So I'm going to jump into contamination for a little while, a couple minutes here. I know we're a little bit behind on time, but we're going to keep going. But contamination is a huge factor. And a big question to everybody out there is it solvable? And who's responsible? Who's responsible for contamination? Next slide. So who's responsible? Can it be solved? As you can see in these photos, this is about, let's see, like, what do we got there? 12, 14 photos. This is an example of a 40 cubic yard load that came in. This is, this is curbside and retail waste, food waste. And you can see all those contamination items there that you see are on the surface of that pile. I didn't dig into that pile. I walked around the pile and just took quick photos. It's a big problem, and it's a big hurdle for us on our end. And we don't have the ability to stop and get out of a loader and remove all these individual items every time a load comes in. It's just not. With the volume and our efforts, it's going to increase. I mean, everybody's moving that direction, which is fantastic, but we got to solve this problem now. So next slide. And a good example is, like, if we don't get that out, when that thing goes through a shredder, that little bottle or whatever it might be, it turns into a tiny little piece about that big, and it's all through the compost. We get out a good majority of it. We really do. We work hard, but still, it's going to be present in the material. Next slide. So yeah, there's a lot of questions here, and follow the money. Who profits? Who benefits? Who uses the products contained in the packaging? Who's mandating or, sorry, I have my little windows in the wrong position, promoting the diversion or disposal? Next slide. So yeah, who's responsible for this problem? Right now, who's responsible? Is it the generators? Is it the packaging producers? Is it the creators of the diversion mandates or the programs? Is it the compost or the haulers? Next slide. The current paradigm is, hey, composter, you got this, right? So right now, that's what's happening. This contamination is there, and it's showing up here at the composting facility, and we're the ones trying to deal with it with high, expensive equipment. And it's hard. So we need a paradigm. What we're going to call it is a paradigm shift. Next slide, please. And let me just get back real quick. So primary sources, what we call in the industry, it's called a ride-along. Call it a ride-along because it comes along with either compostable packaging products, because individuals aren't aware of which is which, and they throw it both in the same stream, or it just gets thrown in there as it comes. Like, you see a nice bin outside someone's house, and you're like, oh, that looks like a trash bin, when it's actually a compostable bin. It gets thrown in there, and then it comes to the site. So go ahead and go on the next slide. So quickly, what are some of the effects? And I'm going to talk about this, and Shawn's going to talk about this. Shawn, why don't you start on the left, and I'll jump back in on the right.
Yeah, so kind of going back to that finished product, we're trying to make a product that we want to put back on the soil that's going to help us with all of the things that you heard about. Going back again to what Helen and Dan talked about, I mean, it was so important to start this presentation with those points. And we're trying to make a resource where we can cycle the nutrients, capture the nutrients from our food waste, and cycle it back into our land. And if we have contamination in that end product, the value of our product is not going to be what it could. And two, it's going to have contamination in our soils. And nobody wants that. We don't want to be hiking down a hiking trail or golfing on a golf course and see little pieces of plastic in our soil. One thing in particular that we have a problem with is broken glass. If there's broken glass in our compost, it comes in with our load, we can't get it out. It goes through the screen and it ends up in the community garden where we get a phone call and all of a sudden it's our fault and our problem that there's broken glass in the community garden and a little kid could cut their feet or their hands on that. So nobody wants broken glass in their compost or in their community garden. And that really impacts us as a composter.
Exactly. And again, like one bottle can turn into a million little pieces. It goes from 1 to 1,000,000 in a very quick time. So again, some other effects, like, of course, it affects the product quality. You know, we have to lower our screen yields. We basically have to process it more. We have to put more hands on this material to get more out. If it wasn't there in the first place, you know, we wouldn't have to do that as much. And again, market impacts, like perception of quality. It might just be a tiny little piece of plastic in a 1 cubic foot bag. It's not going to affect the quality of that black gold, of that amazing organic matter. But it's there. So perception-wise, you look at it, you're like, oh, that's contaminated. That's not good. I shouldn't use that. So it's a tough problem. So next slide. So yeah, again, like I like to call this my little responsibility diagram here. So like, who's on it? We all need to be on it. It shouldn't just be the composter or the hauler. It needs to be everybody. And some examples on how we can be on it and work this. Shawn's going to talk on the top there. I'm going to talk on the bottom a little bit real quick.
Yeah, so it looks like we're running kind of low on time. So we want to get to the innovations for sure there. So, so I think that we can just kind of use this to, everybody can see there's a lot of people involved in touching anything food waste or compostable products before it gets to us. And I think just knowing that every piece needs to take some sort of responsibility in that.
Yeah, next slide. Yeah, so just to retouch on that, you know, it's not all on the composter and the hauler. Next slide. You know, we are part of the solution. Of course, we can impact the narrative, you know, and we can tell everybody and let everybody know what's happening and then the composting methods that are effective. And we're going to get into that real quick with the innovations and talk about like the CMA, for example, great solution. Next slide. So yeah, we need a paradigm shift. Next slide. And that's the solution, the shift. It's going to start at the top and it takes a village. It takes everybody on that responsibility. Everybody needs to be on it. Next slide. Great, so we're going to jump into some fun innovation right now. I'm going to talk about the MSAP and then we're going to jump back to Shawn. She's going to talk about culture shift. Go ahead, next slide. So modified a static aerobic pile, MSAP. And I'm going to go through this fairly quickly because of the time constraints. But this is a new process that we have implemented. We've had the technology for a good 15, 20 years, and we've used it on our biocomp biosolids processing at the facility. But then we noticed how great the process was working. So we decided, hey, let's start trying this on our food waste feedstocks and our feedstocks that are coming in with not only food waste, but also food waste and compostable products and serviceware and materials like that. Next slide. And so a traditional windrow is, you know, a traditional windrow is a pile that you can see in the photo right here. It's going to be there for about 90 to 120 days. We're going to turn it to add the oxygen like Helen talked earlier, 10 to 12 times. On this one, there's no capping. You'll see in the MSAP, we put capping. And on the MSAP, we do an inoculate. And this traditional windrow will work from the inside out. So the temperatures will raise and, you know, the temperatures will go up and go back down from the inside out. Next slide. So on the MSAP, modified static aerobic pile, we're using a traditional windrow where we're creating feedstocks and we're providing a suitable carbon to nitro ratio, adequate moisture. We're constructing a traditional windrow, but at that point, we apply what is called an inoculant that is produced by a partnership we've had with Harvest Quest for many, many years. Bob Yost and Darren Midland have worked on this project for 20 years and have created an inoculant that we add to the windrow. And when we add this inoculant to the windrow, we do it in about 2 or 3 locations. It's just a power pack boost of microbes that will proliferate throughout the windrow within 72 hours. And this, once we've added the inoculant, what we do is called, we cap it. And that's different than what we normally do in a normal traditional windrow. We cap it with like a good 4 to 6 inch layer of wood chips or wood fines or overs, things that we have in our readily available. So the pile, and then the pile will actually sit for 4 weeks, untouched, no turning involved. We turn it at 30 days, we turn it at 45, we turn it at 60. We actually could do this process within 60 days from start to finish. We do it at 90 just because we want to really make sure all of the compostable materials have been broken down completely and everything else. So next slide. But just to talk real quick about what's happening is when we add that inoculant and then we cap that windrow, where basically the capping creates a biofilter, insulates the pile, and contains any loose, lightweight material like a compostable bag, for example. It stays tight and in. And the same thing is when we add those inoculants in the very beginning, the temperature will zoom up all the way through that pile from the outside, right on the edges, where all of that material can be, and slowly goes right into the middle so that it stays consistent, high temp, which is definitely an issue when you're using traditional windrow with compostable materials. And we've seen great success on these materials being broken down quickly and efficiently. Next slide. Trying to go fast. So that was a really quick explanation. We can talk in the breakout session more about it, or you guys are welcome to email me about any information you'd like. But that was really quick. Go ahead.
Thank you. Yeah, so that technology innovation is really important for our industry and for compost. I wanted to kind of also share another innovation in a creative way that I think everybody on this call could be a part of and use as an example. So I want to talk about culture and how important it is for our community to shift in their expectations of composting. And in my community in the Vail Valley, we see these little tents with compost, recycle, and trash, and that is a norm. People in my community, they know that they're expected to compost. We go into all the schools. Every single school in my community has had a presentation from me and my wonderful team, and we go in and we talk to the kids about composting and recycling, and everyone in my community has an opportunity to participate in composting as well through our drop sites or our programs for their business. So there's a lot of opportunity, and I think it's really about that expectation, and we're going to see future generations expect this. So Tenzin, oh, sorry, go ahead, next slide. And so this is kind of getting to the heart of where we started our presentation of how do we make composting sexy? Like, you know, we want it to be cool, and composting is so gross and everybody just thinks of the nasty food waste. And so, so I wanted to use this really cool example of the Burton US Open. The Burton US Open is the largest snowboard competition in the world, and it happens in Vail, Colorado. Vail Mountain, and I am just so proud of this, and it really was the partnerships that made this all happen. And so we were able to achieve 83% waste diversion in 2020 through composting and recycling and partnerships of the Burton US Open. And you can see on the bottom right, there's a picture of the half pipe. You can see that half pipe is lined on both sides and all the way at the bottom with people that come from all over the world for this event. And next slide. And so it's really important that we get that culture of waste diversion. That's important to our community. Vail Resorts requires that in all events. I'm sorry, the town of Vail requires that in all events. And this really started months and months ahead of time when we worked with Vail Resorts as their waste provider and as their composter to train their staff on composting and to ensure that they have the right products in their kitchen. So, next slide. So we were training in November. We were already training people. And the other part of the partnership that was really important was our partners with Burton, the event organizer, but also Walking Mountain Science Center, our local nonprofit that does education. And you can see all the trash piled up. They went through every single bag and sorted everything out. Next slide. And this is what I look like at the end. I'm so proud of this, that you can see they built an entire village, and anyone who's in recycling or composting can see that and say, wow, that is really clean stream. And so it was really the partnerships that made it happen. Next slide. And really going back to Burton being the leader on this, you know, they have the athletes talking about waste diversion and how important that is and how important it is we recycle and compost. And, you know, it may seem like kind of gross, but it gets really sexy when your favorite snowboarder is up there talking about how important recycling is and why we do that at this event. So,